To find the greatest common factor a little more quickly, it would be faster to list the factors of just one of the numbers and then see if any of those, to see which of those factors would be able to also go into 27. So if we start with 18, 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. You can't multiply 4 times anything to get 18. You can't multiply 5 times anything to get 18. 6 times 3 is 18, but you already have those listed, so you know you're finished listing your factors of 18. Now to find the greatest common factor, you start with the highest factor of 18, which is 18. And you see, can anything times 18 give you 27? Since it can't, you'll go to 9. And you ask, can anything times 9 give you 27? Since 9 times 3 is 27, 9 is the greatest common factor. By starting with the highest factor, you're going to find the greatest common factor more quickly. And number 2, we'll list the factors. We can list it as either 32 or 72. Typically, the smaller number has less factors, so that's usually the better bet. 1 times 32 is 32. 2 times 16. We can't multiply 3 times anything to get 32. 4 times 8 is 32. We can't multiply anything times 5 to get 32, nor 6 or 7. 8 times 4 is 32, but we already have those factors listed, so those are all the factors of 32. Starting with the highest factor, 32, you have to see if anything times 32 will give us 72. Since it can't, we'll go to 16. See if anything times 16 will give us 72. If that won't work, we'll go to the 8 and see if 8 times anything can give us 72, and it can, so our greatest common factor is 8. When you have 3 numbers to find the greatest common factor of, you'll follow the same steps. List the factors of any one of the numbers that you want. Pick 21. 1 times 21, can't multiply 2 times anything to get 21. 3 times 7 is 21. We can't multiply 4, 5, or 6 times anything to get 21. 7 is already there in our list, so we've listed all of those factors. Starting with 21, the highest factor, can 21 times something give us 42? Yes, it can, but we can't multiply 21 times anything to get 56. So we're going to have to go to the next factor, 7. 7 times 6 is 42, 7 times 8 is 56, so 7 would be the greatest common factor for 21, 42, and 56. Number 7 is a word problem, and it's telling us that the florist has 16 red roses and 20 pink roses. And we need to see how many arrangements can be made so that each arrangement will have the same number of red roses and the same number of pink roses in each arrangement with no leftover roses. Make sure we use all of them. So when we want to find the greatest number of arrangements, we're going to find the greatest common factor. So if we list the factors of 16, 1 times 16 is 16, 2 times 8 is 16, 3 times, I'm accidentally listing 18 here. We can't multiply 3 times anything to get 16. 4 times 4 is 16. Since that's a double, you're already repeating, and we can try to find the greatest common factor now. We can't multiply 16 times anything to get 20. We can't multiply 8 times anything to get 20. But 4 times 5 is 20. So 4 would be the greatest common factor. So that would make 4 the greatest number of arrangements that can be made. Now if we want to take this a step farther, I can then ask how many pink roses and how many red roses would be in each of the arrangements. Since we're making 4 arrangements and we have 16 red roses, we would have to separate these 16 roses into 4 arrangements evenly. 16 divided by 4 would be 4, so we would have 4 red roses, and then we would have to take the 20 pink roses, divide that by the 4 arrangements, and that would give us 5 pink roses. Moving on to lesson 4, where we're changing decimals into fractions and fractions into decimals. Starting with number 1, you first need to know how to read the decimal, because that decimal name will give you the fraction to write. This decimal is 15 hundredths, so we write the fraction 15 hundredths. But we do have to put the fractions in simplest form. So we have to see if there's anything that can go into both 15 and 100 evenly. Since 5 can go into both 15 and 100, we need to divide and reduce the fraction to 3/20. Number 2, we have a fraction that has a whole number in front, so this is going to give us a mixed number. Sorry, this decimal has a whole number in front. So this is 1 and 25 hundredths, so we're going to have a whole number in front of our fraction. That would be 1 and 25 hundredths would be the mixed number there. Then we have to see if we can reduce the fraction. Since 25 can go into both 25 and 100, we need to divide by 25. Don't forget to bring the whole number over before you reduce the fraction. So 1 and 1/4 would be our answer. For number 3, this decimal name is 43 hundredths, so we write it as a fraction, 43 hundredths. There's nothing that can go into both 43 and 100 evenly, so 43 hundredths is the reduced form. Now to do the opposite, to change a fraction into a decimal, we have to remember that this fraction line stands for division. This means 2 divided by 5. So we're going to divide 5 into 2. Since that doesn't go, we're going to add a decimal and 0. 5 into 20 is 4, and that gives us our decimal of 4/10. For number 6, when you have a whole number in front of the fraction, when you have a mixed number, bring the whole number over first, and then you would do the same type of division. Here we would have to divide 8 into 7, which doesn't go, so we'll add a decimal and a 0. 8 into 70, we go 8. 8 times 8 is 64. We still have a remainder, so we have to keep adding zeros and bringing them down until either the remainder goes away and we have a terminating decimal, or to the digit is repeating, and that's called a repeating decimal. 8 into 60 is 7. We still have a remainder and nothing is repeating. We keep getting different numbers to divide into, so this is not considered a repeating decimal. 8 into 40 is 5. Terminating decimal because 875 hundredths is our answer with no remainder. For 2 and 5 6, we can bring the 2 over first, and then we have to divide 6 into 5 to get the decimal part of the answer. Add a decimal and 0 and divide 6 into 50, which would go 8 times. 8 times 6 is 48. We get a remainder of 2. We'll bring down another 0 and divide 6 into 20, which is 3. If you notice this time we get another 2, so when we bring down another 0, we're going to be dividing into 20 again. At that point we can tell it's going to repeat because 6 into 20 would be 3 again. 3 times 6 is 18, and we would get another remainder of 2. When you notice it's repeating, you stop dividing and you put a bar over the repeating digit. So our answer would be 2 and 83 hundredths with the bar over the 3 showing that it repeats. We're going to use that skill to help us put these fractions and decimals in order. In order to put these in order, as the directions state, it's least to greatest, we have to first change 2/3 into a decimal. To change 2/3 into a decimal, we're going to divide 3 into 2. Now when we're dividing, we have to keep in mind that we're trying to compare and place 2/3 in order with 78 hundredths and 21 hundredths. Since both of these decimals have 2 decimal places, we're going to need 2 decimal places for our quotient for 2/3. 3 into 20 is 6. And 3 into 20 again is 6. And this is one of those repeating decimals. But because we need 2 decimal places to compare and order these numbers, we're going to go ahead and use the 66 hundredths so that we can tell where it falls in line with the 78 and 21 hundredths. We're going from least to greatest. 21 hundredths would be the least. Since 66 hundredths falls between these two, 2/3 would be second, and 78 hundredths would be the greatest. For number 11, if you notice the first decimal is 52 hundredths, the last number given to us is 3/10. First thing we want to do is even that out and make them both into hundredths. Now we can change 1/9 into a decimal by dividing 9 into 1. Keeping in mind once again, both of these decimals have 2 decimal places, so we're going to want 2 places in the quotient when we're dividing down here. 9 into 10 is 1. 9 to 10 is 1. Once again, we have one of the repeating decimals, but we don't have to keep dividing, and we don't have to put a bar. What we want instead are the 2 digits, 11 hundredths, so we can use that to put these numbers in order. 11 hundredths is the least, so that means 1/9 would be the lowest value, 3/10 would be second, and 52 hundredths would be the greatest.